Hi, in my last video we have built successfully a PCI device which is emulated by QEMU, so our PCI Echo device. But we have a small problem. When we are starting our virtual machine and executing lspci, we can see our device but we can't get any more information about it. The reason for this is we're using busybox lspci, which is very stripped. So the goal for today's video is to grab the pciutils, which comes with a better lspci, and cross-compile this for our ARM virtual machine. So let's start. The first thing we need is we need a copy of lspci, and this we can find on the official lspci page. So just copy this link here to this Git repository and let's clone the lspci's Git repository. Done. And what we can see here is lspci is built over a makefile. And in this makefile we have a bunch of variables we can set. So normally I would set these variables dynamically during the compiling process, but here I would have to set a lot of variables, so it's easier for me to set them within this makefile. So our host is Linux. We want to build a lspci for Linux. But we want to cross-compile it for ARM. And here we have to give it the path to our cross-compiler and the name of our cross-compiler. So here is the path. So we will echo the path and also, yeah, this is what I need. So here is the path and the name of our cross-compiler. And I will add this in here. Then we have some options which will make lspci even more nice. For example, in here, PCI Express offers a resolving of the vendor and device ID of PCI devices, but therefore it would need the setlib, and I don't have it, so I will set this to null. Also I will set DNS support to null, but I want to build it as a shared library, so I will put this to yes. Then there is a module available to resolve which PCI or which driver is used for a PCI device, but I also want to use this here. And a HopperDB, it would need libutef, which I also not have, so we'll also set this to no. And this is all we have to change here in the make file. Now let's run make and build this, and let's build it with only 4 threads here because it's not so much, and so we don't oversee any error messages. But this is looking quite good. Okay, so now we have built setpci, lspci, and in lib we can find our libpci as a shared library. And if we take a look at the file, let's take lspci, we can see it's built for ARM 32-bit executable. But we have a small problem. With readof we can see which libraries are needed, for example from setpci, and we see here we need libpci, which we've compiled, but we also need the clib, which is part of our cross-compiler. So we have to add this into our root file system. So let me navigate into my root file system. And in here I will create a folder called lib for the libraries. And the first thing I will do is I will copy libpci into my new lib folder. Okay. And then we need to find our clib and also copy it into our root folder. So in order to find clib, I will navigate into my cross-compilers folder, and I use find in the current folder a file with the name libc.so6. And here we have it. So let's copy this file and let's copy it into our root file system libraries. Okay, but now we have to check if our libc needs some variables or needs some libraries, and we can do this with readof -d. And here we see we need this library. Okay, so once again, we need to find this library. And here it is. So now we can copy it to our rootfs lib. Okay. And of course we have also to check if this library needs any more libraries. Yes, it does. So we need our library name resolved. No, it doesn't. So here we don't need any more libraries, which is great. Okay, and now let me go back to our root file system. And let's copy our pciutils lspci into user bin, and I will call it my lspci. And setpci I will also include in my rootfs. Setpci. But as there is no setpci available, I can't overwrite anything. So here in user bin, if I do a store pci store, you can see now I have the original lspci from busybox, our new compiled lspci, and setpci. Okay, now there's one last thing I want to do. So I've built my busybox statically, so I don't need any shared libraries. But as I already had to include the libc, now let's go into the menu config of busybox and select to build it as or without the as not a static binaries. So let's build it with libs because we have the clib available anyhow. So let's exit this, yes, and let's build it once again. Okay, this is done, and now if I'm doing the readelf again, we see we need these 5 libraries. So we have to find them too. So let's go back to our own compiler, find, this is the mathlib, or so in this folder name, here we go, and let's copy this library to rootfs lib. And the same is for this resolve lib, but I think we maybe already have added this. Let's check it. And then let's copy it to rootfs. Okay, cool. Then let's run make again with install to put everything in this install folder. Oh, we're on the toolchain. I have to go back to busybox. Okay, make install. And then cp everything from the install folder into our rootfs. Done. So last step is to go into our rootfs and to add everything to our zipped or rootfs cpio.gzip. Okay, done. And now we can go back to our QEMU build and start QEMU once again. So let's start it. Done. And now I have my lspci available. Okay, maybe let's rename our libpci to libpci. Yeah, now it's working. I have this name set up wrong. And now I can do something like S, so for seeing more options of one device, this device and VVV will give us more options. So now we can see here, this is a PCI device with the class FF. The device ID, this is the vendor, this is the device ID. The subsystem device ID we haven't set in our device, so these will be QEMU's defaults. We have one bar mapped with memory mapped at this vertical address, and it's 16 bytes in size, and we have a second bar at this address with 4 kilobytes in size. So this is looking really good. And let's also test if setpci is working. So therefore we have to specify our device and the thing and what we want to read. So if we read the command bit here, hey, we've read it out successfully, or the vendor, for example, ID, not working correctly. But for example, if you're reading the word from offset 0, yes, we're getting the vendor ID, and the word from offset 2, we're getting the device ID. So lspci and setpci are working correctly. So great. So I guess that's for today. I hope you've enjoyed the video and learned something. And in my next video, we'll start implementing a PCI driver for our custom PCI device. So thanks for watching, and goodbye.